In this video, we're going to find two different ways to solve this differential equation. The first way, we're going to make a substitution. We're going to let y equal vx. So then the derivative with respect to x becomes dy over dx equals dv over dx times x plus v. And this is just applying the product rule. And so now I'm going to make a substitution. So I'm going to take this original differential equation, replace y with vx, and then dy over dx is going to get replaced with dv over dx times x plus v. And at this point, let's square the v and the x to get v squared and x squared. And then we're going to multiply that by 3x to get 3x cubed v squared. And now we're going to distribute the 3 here to v and x to get v cubed and x cubed. Now I can divide both sides by x cubed, subtract v cubed, and divide by 3v squared. So those two steps at once. My goal is to solve for dv over dx, so let's continue by subtracting v. And now I can just divide both sides by x, and I'm left with a separable differential equation. So let's move the v's on the left, the x's on the right. Multiply both sides by 3v squared over 1 minus 4v cubed. And then multiply both sides by dx. At this point, I'm going to integrate. And for the integral, I'm going to do u substitution by letting u equal 1 minus 4v cubed. And du is negative 12 v squared dv. And when I solve for 3v squared dv, I just get negative 1/4 du. And then, obviously, ln of u, or du over u, becomes ln of u, which u is 1 minus 4v cubed. So that's how I get to the left. And on the right, I integrate and get ln of x plus c. Multiply both sides by negative 4. Now I'm going to do e raised to both sides. E the natural log are going to cancel. I'm left with 1 minus 4v cubed. And then this negative 4 just is the exponent of x. That's x to the negative 4th. And then I'm going to have e to the c multiplying that. E to the c is just a constant, and here I just called it a. My goal is to solve for v, so let's subtract both sides by ax to the negative 4th, and then add both sides by 4v to the 3rd power. Divide by 4, and then take the cube root. Now I'm going to do some more math and get a common denominator of 4x to the 4th. So the first fraction, I'm going to multiply x to the 4th over x to the 4th. Second fraction, I'll multiply top and bottom by 4. Bring it all together by subtracting. And then at this point, I'm going to substitute back. So originally I made a substitution where y is equal to vx. And so v is equal to y over x. Make that substitution. Multiply both sides by x. And now this x to the 4th inside. So I have on the bottom here basically x to the 4th, the cube root of that, which is x over x times cube root of x. And the x's cancel, so I'm left with 1 over cube root of x. Okay, so that's basically what happened with this x, ignoring everything else. So this x to the 4th and x canceled to just cube root of x. Now let's look at the second method. The second method is just using exact equations. So let's subtract both sides by x cubed, multiply by dx, and now take the derivative of y cubed minus x cubed with respect to y. And that's the same thing as taking the derivative with respect to x of 3xy squared. They're both equal to 3y squared, so we get an exact equation. Now I just chose to let f of xy to equal the integral of y cubed minus x cubed with respect to x. And I set that equal to c1. Okay, so this is going to be my solution. So now I need to take the derivative of what I just found with respect to y. And I got 3y squared times x plus g prime y. And set that equal to this part right here, to the first part. So I integrated this one with respect to x. Now I'm going to take that and then take the derivative with respect to y and set equal to this. Well, clearly they're the same. 3xy squared is the same thing as 3y squared x. So g prime has to be 0. In other words, g has to be a constant. So now I go back to the second step here, and I replace g of y with a constant. So let's take f of xy and solve for y now. So let's get rid of the c2 by subtracting both sides by a constant. I get another constant. I just called it c1. And then I added both sides by x to the fourth over 4 divided by x cube root, and just got a common denominator of 4x, and this is my answer.